So I just want to wish everyone a good evening and welcome to the WiCyS research-led teaching event tonight. I'd like to introduce Anne Cool, our WiCyS Australia Chair of Communities. Thank you, Anne.
Hello and welcome. To start with, we would like to acknowledge the traditional custodians of the lands on which we meet today and pay our respects to their elders past and present. We extend this respect to Aboriginal and Torres Strait Islanders peoples here today as well. So I'd like to introduce you to our panel members. So first we have Dr. Elena Sitnikova, who's an award-winning academic and researcher at the University of New South Wales, Canberra, and through the Australian Defence Force Academy. Elena is a global leader in CI cybersecurity and IoT, and she practices the research-led teaching in her courses and therefore will be our chair today. Our next panel member is Dr. Anna Kusk. Anna determines strategy, designs and implements data integrations between machines and business systems to automate data-driven decision-making in engineering-based organisations. Our third panel member is Dr. Jessamine Madoni. Jess is the Chief Engineer for the Australian Cybersecurity Centre and a doctoral student at Uni of New South Wales, ADFA. Jess also holds 5 master's qualifications in cybersecurity operations, systems engineering, space operations, project management, and international relations, security. And then there's me. My name is Anne Cool. I've worked in IT for around 30 years, and I also completed a master at Uni of New South Wales a few years ago. I've since authored papers and presented at the ARIA conference alongside leading researchers. And I'm currently an IT and cybersecurity consultant working in industry. In this panel session, we ask the question, how can cybersecurity be taught so that it is interesting, engaging, relevant and up to date when the cyber ecosystem is constantly changing? Is research-led teaching the right answer? We might find out tonight. WiCyS Australia has brought together a panel of academics, industry professionals and former Uni of New South Wales Canberra master students to share our experiences of how research-led teaching has impacted our lives and our careers. Let's start by asking Eleanor, as the leader in this field of cybersecurity who practices research-led teaching, Eleanor, perhaps you can explain for us what is research-led teaching?
Thank you, Anne, for very nice introductions. Yes, today we'll be talking about research-led education. It's a known approach in many fields of teaching. So it's not only discipline related to cybersecurity, it's a known pedagogical approach when the researchers, they're bringing their articles, their outcome from their research to their classes. And the students, they learn from these research papers and research particular demos or particular the practicals which are very current in their classes. But research is very important for students, especially on master level courses, because it encourages them not only learn from those papers which their instructors and other people who involve into their courses like tutors or guest lecturers who bring the industry practices and industry real life examples to the classes, but they also benefit from doing research themselves. And that's what for so many years I've been practicing in my classes. What that means, it encourages students not only read the papers, which I'm as an actual active researcher provide to them, and it's up to date and relevant information, but also I construct the assignments the way where students have to communicate to each other. together through the special forums or work together in a specially designed projects and provide the research, like case study, for example, one of the assignments they have to do. In those assignments, they not only read and understand what's in the current research, but encourages them to do critique analysis, discuss what's in a paper, and provide their own opinion. Sometimes it's argumental opinion by writing the very good academically sound pieces of papers which are high relevant for their education. And that's what we call research-led education. And today we will be talking, because I invited my students who were in my classes and who adopted that approach, and they now using these skills they gain in my courses in master level in their work spaces, where they can write reports to their peers, or they can write the executive summary to their high executives, and so on. So that's a little bit introduction to some who is not familiar with what it is research-led education or teaching, and that explains how we do. But today it's a session where I introduce you to panel members and who addresses a question, and there will be clarifying more how it works in practice. Okay, so my first question is to Jess, who is my panelist. She was, I think, remind me, Jess, it was 3 years ago where you were in my class.
Yeah, something like that. Yeah.
Yeah, and since that, time passed, and Jess is now my professional doctorate student, which I supervise. And also Jess provides very valuable input to my classes. She comes as a guest lecturer and talks about specific for cyber governance and bringing her experience to my classes, and also helping with tutorials in classes. So Jess, you've been in classes and now you practice in my also courses, what we propagate. My question is how to design cybersecurity courses to engage full diversity of students?
Yeah, definitely. That's a great question, Elena. I think to start the answer to that question, the main thing is that, cybersecurity is everyone's responsibility. So it's easy to think that cybersecurity is just for IT professionals, but it's not. Cybersecurity is important whether or not you're just trying to increase your own personal resilience, whether or not you're the receptionist at a company, or whether or not you're the CEO of a company. Everyone really plays a key role in that, and therefore everyone should be studying cybersecurity. I think we're starting to see a bit of a change in recent years. If you think about, how boards of large companies are made up, normally they have, like legal representatives and, like a range of people, but now boards are all starting to add a cybersecurity specialist. And that's across all industries and all sectors. So it doesn't matter whether you work in the healthcare industry or whether or not you work in another area, cybersecurity is absolutely critical. So it's really important that we design courses that aren't overly technical and that cover off that full breadth of cybersecurity. So if we take, the cybersecurity spectrum, we've got passive security, which is why it's so important to, not click on phishing emails and to be aware of social engineering. Then you've got defensive cybersecurity. So that's getting a little bit more technical in some spaces, which is, hardening systems, all the way over to offensive cyber. There's a lot of different roles, a lot of different areas to specialise in, and a lot of areas of study, obviously, across that spectrum. So definitely important to attract a range of students from different sectors so that we can make a difference and improve, especially Australia's cybersecurity posture. I guess the other thing just to note on that one is we need to design courses that attract a range of people, because diversity of thought is also really important. So not just students that might work or come from different, backgrounds, in industry, but also different backgrounds and different ways of thinking, so that we have a diverse representation.
Yeah, it's great, Jess. Can you just clarify that, because you were involved into when the students were doing some case studies, and there were some of them were saying to us, how I can participate? I have a limited IT background, and we placed them in the groups, and that worked very well. So what's your opinion about that when you hear the feedback from students, how they work together and produce the reports?
Yeah, I think that's a myth that we all need to help bust. There's, a bit of a stereotype that you've got to be a software developer and you've got to come from a particular technical background to be able to study cybersecurity or even understand cybersecurity. It's kind of shrouded in a whole range of myths. In that class, whether it's classes I've been in with you or classes that I've helped you, teach and mark, it's worked out really, really well. And in all cases, whether those students have come from an international relations or policy background or wherever, they found this all very, very valuable. So yeah, I think that's a myth that we can all help to bust.
Yeah, thank you. It was very great answer. We now move to another question we hope we can address now. I can see Dr. Anna Kilsk is here. Hi, Anna. My relationship with Anna started many years ago when we worked in a project together, helping students to work together in teams. It echoes what Jess was telling us about importance students, and especially in cybersecurity, when cybersecurity is everybody's business. It doesn't necessarily mean that you need to be a technical, very strong. Everybody who deals with the computer systems, they have to be aware and be educated. So that's how we started. And our last engagement was through Master by Cybersecurity project, that the thesis we supervised together. So Anna, we lost your video. I hope you can be back, because your question, yeah. So, and it's an interesting, because we're now talking about how we work in teams and students work in teams, that supervising students who lived in Perth and being associated with University of South Australia, and now I'm living in Canberra, and you co-supervise with me in Adelaide. So it shows everything is possible. Yes, and thanks for joining us. My question to you is how to explore the impact of research-led teaching on learning, students' learning. Thank you.
Yeah, I got quite a lot of different experience in terms of I've done a lot of consulting in project management and auditing and implementing different types of systems, engineering systems, IT systems, and integrating those through automation, robotics, IoT, all of that sort of stuff. But I've obviously been working longer than I have teaching. So I spent about 25 years working in technology. And also in terms of about 20 years in terms of teaching as well, and being involved with organisations as research adjuncts and those types of things as well, in terms of bridging between organisations such as BHP and BAE and their investments in research centres with the different universities as well. So I've seen different angles, and particularly in terms of supervising PhD students, as Eleanor had pointed out. And in terms of the impact of research-led teaching, in particular with cybersecurity as well, being probably one of the newer, I suppose, engagement governance areas that impacts all parts of an organisation, is that there's impacts in a good way for students, and there's also impacts in a good way for practitioners and academics such as myself. So, for example, in terms of the student that Eleanor was talking about, as a colleague of mine in a mining organisation, And he was on one side of the country, I was on the other. We were both working in control systems as well, and in security. So I was auditing a lot of control systems on petroleum rigs and conveyor belts and things like that in terms of mining processing, and so was he. And in terms of my industry experience coming to supervise with Eleanor with that student, was that I was able to bridge between the industry practitioner and our expectations in terms of academia as well in terms of the research. So for the student in particular, I was able to, I suppose, bridge and speak a little bit of both in terms of industry practitioner and also in terms of academic expectations. So the student was able to maybe have a smoother experience in terms of going from practice to academia. In other examples, where we've had projects, where we've had teams of students who are doing industry projects with real clients, with real problems, and having to implement complex systems, design them, and then also implement them as well, is that those students actually get a very good experience with the organisation of transposing their theory into a real world life practice before they go out into industry. So they're very, very job ready. And in a lot of instances, the best students have actually been picked up into the organisations that I've exposed them to, or that I've been working with, and working with those project teams with those students. For me, my research, I suppose, informs my practice informs my research and practice informs my teaching, and allows me to keep up to date with what is really the best in terms of tools and applications to be able to advise organisations, but also to be able to advise students as well in terms of when they come in, they say, well, what should I actually be focusing on in terms of the tools and applications that I should be getting up to speed on, or advising organisations during my actual project and industry-led projects as well. So the impacts are really, really great in terms of for both aspects, in terms of the PhD research students, master's research students, honours students, our final year students in technology and engineering, in terms of doing those industry-led projects, and for us as practitioners and academics as well. We all get something out of it.
Yeah, that's a very good point. Thank you. And that's what I say to my students. We're all colleagues, because some students in my classes, they already have so much experience. We share knowledge, we discuss that, and we all benefit. And with the research-led teaching, where we tell them that this is not the only course you're doing, you're taking with you those skills to research, to combine the knowledge, reflect what we were teaching in a right way, and you continue doing research. It's an area which is always evolving. We're now all interconnected. So this is very great what you highlighted, because your career is very amazing. You were in industry, you were also doing your PhD, now you're with industry, and plus you're working with university with a final year project. Thank you for your insight, Anna. Next question I have to another panelist in our group, and and hello, cool. So how to foster the development of analytical skills and the sense of purpose that extends beyond specific master program? You're muted. You're muted.
How often do I do that? So research-led teaching for me went way, way beyond the theory. So I have used the research skills that I learned to participate beyond the Cyber Masters, and to write papers that I can share with a broader conference and industry audiences. I was able to apply the analytical skills that I learned and the cyber knowledge and the research capability in my consulting role. And particularly while I was implementing a large-scale cyber cultural program across one of Australia's largest banks. I've come away with a whole breadth of new skills that I can apply every day. It's fantastic.
Yeah, that's great, because we can explain a little bit our engagement, because you were as Jess in my class, and you know, when you design the course materials and then design the assessment, which assessing how students learn progressively through the first week up to the 13 weeks of the whole course, we encourage them to develop skills gradually, and then the last portion of the assignments, it's usually the major assignment. That's where they demonstrate the high skills. And as an educator, you know, every assignment is designed to be a solid credit. So it's designed for average who is in my class. But I always encourage people to do more than just a credit. And Anne was one of the students, one of the brightest students I ever had. So she really liked the way we teach. She got that research-led education so clearly, and she, after we finished the course, I think it was even next semester or semester after, we said, Anne and other students, your assignments are high distinction. Why don't we sit together and we lead you towards the publication in high forums like conference, but we targeted even journal. That was very, very, I would say, brave, but we made it. So from the assignment, which was, you know, assigned to the topic for the student, you grown up to the communicating to the people, to peers who are all over the world looking for the best papers, and your paper was one of the best. And now we're talking that you might join us for high degree education to continue with us. So that's great. Thank you. So we have another question which we prepared and promised. If you read our leaflet, what we said, that research-led education, it's not only us, we're so excited, we explained to you. The fourth point was how prioritize student development of new skills suited to resilient and sustainable workforce. And I would like to address this, pose that question to Jess, who can address it. Thank you, Jess.
Yeah, definitely, Elena. So I guess cyber is a really broad and changing discipline. There's a lot of myths, like we discussed before, that, you know, the cyber workforce is just super technical people in black hoodies with lots of like ones and zeros coming down in the background. But really that's not true, because cyber is so broad and because it's always evolving. There's actually a huge range of skill sets and people required to fill those roles. So we need people in the workforce who have skills and resilience to be able to adapt to that ever-changing discipline. And we need a range of different, you know, people who can think differently and people who can really help us tackle all of the problems that come with cyber. And that's not just technical people. In fact, I mean, if I think about the organisation that I work in, which is the Australian Cybersecurity Centre, the large majority of people that work in the Cybersecurity Centre are not the nerds in cargo pants and hoodies. We have a whole range of people, from people writing cybersecurity policies and figuring out how we're defining critical infrastructure sectors and what that might mean, and policy for government, and, you know, hardening, and all the way through to, you know, areas that are looking at future planning and laboratories for emerging technologies. Huge range of different skill sets. We can't just hire the same types of people who are the technical software developers. So in that, we really need some diversity of thought, which is another theme that we've touched on. So I guess to answer the question though, to be able to support that, there's probably two things that universities really need to do in the way that they design courses and teach students and prepare everyone for industry. The first is, I guess, allowing students to understand the cybersecurity environment. Because it is so broad, as we've discussed previously, there's a lot of different, areas that, I don't think it's possible for one person to be a cybersecurity policy expert, but also an expert at reverse engineering malware. There's just so many different areas that you can be excited about and passionate about and get involved in. So the first thing is really, and I think, the UNSW cyber operations course and the broader cyber course is a really good example of this. You've got those core subjects that teach you about, just like the fundamentals of, what is cybersecurity and what's involved in that and what's information assurance. And it helps you understand everything that is out there, and it helps you just kind of situate yourself, but you still kind of understand that bigger picture, even if you do go down a particular path. The second thing that I think unis can probably help students with is not teaching them overly specific skills, but teaching them skills that will equip them to change as cyber evolves and as threats change and as roles change. And I think those key skills are things like, risk management. It's really surprising to me how many cybersecurity professionals in the workforce don't know basics of risk management and how to really apply that tangibly to problems. On top of that is obviously problem solving, complex problems like thinkings and critical analysis type skills. So really that's really that research-led approach, not just rote learning and memorizing a textbook or memorizing what CIA stands for. It's true applied skills. The other thing that I think has really helped me, at least, is understanding like engineering processes and how that can be applied as well, which is really important if we're talking about cybersecurity resilience. So I think those skills are important for any level, no matter whether or not you are a senior executive, or whether or not you're in a graduate program, or whether or not you're just deciding that you want to change your career and you want to study something new. And it will just, those skills are enduring and they help you tackle any problem. And I think cyber is just so crazy. Like cyber 5 years ago was different to cyber today. And the threat could change in 5 years' time. We might decide that aliens exist and perhaps they want to hack us as well. So it's important that we're all on our toes. And by having those, and learning those enduring skills, you can do anything.
Yes, thank you, Jess. That's actually was another question you already answered, because a lot of students were asking me when they join our program, they say, I already hold the certification in CISP or Security in Lifecycle Professionals through IC². Can I be exempt from your course? Because it says it's based on that certification, you provide some materials. I said, yes, but it's different to the certification. And that was my question to you as a professional, and you've seen a lot of people taking professional courses or certifications, that what's the difference between the major difference in master level program to compare with others certifications?
Yeah, like I think that's a great question. And I think like they're apples and oranges. If you take like a professional certification, especially in say cybersecurity, take like a CISP or a CISM, that is really a test of how well you can memorize a textbook overnight. They're not applied skills. So you will literally have textbook knowledge, but there's no way that you'll be able to apply it. So the people that I see doing a CISP or a CISM or those kinds of industry certifications are generally people who have worked in the field and they've got something to prove, like they need to get a promotion, so they do that certification so they can get the piece of paper to demonstrate that they do have that, that academic textbook type knowledge of things. I have done my CISM and it didn't teach me anything. Honestly, it was, it's a great piece of paper, but other than that, it's not worth your time. And it's just not remotely comparable to research-led teaching that actually teaches you enduring skills.
Okay, thank you, Jess, for a very good insight into that and experience. Yeah, I can add to the skills we developed in master level. It's according to approach, which I first read through the engineering, the Royal Academy of Engineers in UK, they talked about T-shaped knowledge. And when I start every course, I say, that's what we teach, a T-shape like that. So where the base of a T is that specific knowledge for that course. So if that the course cyber defense, you will be learning how to defend the systems. If it's a reverse engineering, the skills for reverse engineering and so on. But the top of that T-shape, it's a broader knowledge that you need to know about complexity, the systems, the engineering processes. That's what we all said through the panel. And you hear that Anne Kusk said and Jess said, and we discussed that with other people here. So that's what we're really strong on that. And I think this is the way how we should provide the education to the students. And I would like to invite everybody to my classes, but I'm a little bit biased here. Okay, maybe I will turn back to Jane if there are any questions from the participants.